new session. So you're good whenever you get ready. You can go ahead and start 2 o'clock or whatever your
Yep.
style is. Yeah, I'm gonna go check out the next meeting.
Cool. If I can. Time screen. We got 3 minutes before the session starts. The weather is pretty nice here today. I'm here in Texas, in the DFW area. Very interesting. Okay, we'll get started. Okay. All right, good morning, good afternoon, good evening, everyone, wherever you are in our virtual world. My name is Ron Dagdag, and today I will be doing a presentation about developing your inner Spidey sense. It is an anomaly detection for applications. I'm going to focus on Internet of Things application today. Spidey sense, if most likely every one of you have already heard of Spider-Man and have heard of his Spidey senses. What is this Spidey sense that Spider-Man has? It's his tingling sensation that on Peter Parker's skull that makes him that extra sensory perception, right? In a way, ability to react to danger before something happens, before he uses it to detect evil or even his clones, right? He uses it to navigate if he is impaired, disoriented, or unable to see or hear. It enables him also to find hidden objects or passageways, of course, his web shooters, his famous web shooters that he can definitely swing instinctively. And I think he also uses to change to his Spider-Man costume, so nobody can can see what he's doing. Real Spidey sense in real world is what we call hyper awareness. Spiders have these long, thin hairs called Tychobothria. Tychobothria is can allow spiders to be able to detect low-level vibrations, even sounds through their spider web. If anything, moving even up to 3 meters away. So it's like extra sense that they have to be able to detect danger, or if in case it's a small insect, they may be able to attack and have dinner. Of course, if you're a new web developer, it feels like this. You start throwing out there the web and nothing nothing happens. Of course, everyone start when you're starting to learn. So Spidey sense for us, my definition of it is, it's that gut feel, right? It's that feeling or that intuition that discovers or helps us discover blind spots and what we've learned in the past. Uh, what it allows us to be able to, if you think about it, like if you're an expert in sports, right, or an athlete, they have lots of time, lots of practice, and because of that practice, the 10,000-hour rule, it it's like in baseball, they don't even have to think where to hit the ball, right? Or even in basketball, it's not conscious, it becomes unconscious, it becomes that Spidey sense that, hey, this is the best place for me to shoot the ball or throw the ball, those kind of things. Of course, the way I kind of understand also in the programming language world, right? There's that low-level programming, and in between you have and also the high-level programming languages, and then of course the high-level programming languages gets converted to using the compiler to run low-level programming languages. And so in our bodies too, you have the instinct and intuition. Once you learn how to walk, you know how to walk. That's part of your instinct, in your balance. And then intuition also, when you sense like that danger, right? There's sometimes you feel like someone's watching you, that kind of thing. So that's how I kind of define the Spidey sense here. And of course, there's that interpreter module in our brain, and of course the active one is the insights, right? The unconscious, the conscious is where you have your insights. So today, our agenda will be talking about anomaly detection. We'll focus on time series anomaly detection. We'll do a demo and takeaways. If you have any questions, feel free to type it in the chat. I'll be happy to answer them for you. At the end of the presentation or even in between, we'll work on that. So anomaly detection is the is identifying unexpected things. Today we live in this unprecedented times. We all attending conference at how virtually, right? It's so weird. It's so unusual, and there's that. It's an outlier. It's out of the norm. Of course, maybe it's the new normal. We don't know, right? And the assumptions are the anomalies occur very rarely in the data. So last time we have a pandemic, it was 100 years ago. It's very rare, and then their features differ from the normal instance significantly. It's totally different from the usual set of data. So of course, the causes of outliers or anomaly are either artificial or non-natural or natural, right? Artificial means, most likely it's man-made versus natural. So what can be causes of it? Could be data entry errors. So if you have your data, you add extra zero instead of 100,000 versus 1 million, right? It's when you have fat-fingered some of your data. Measurement errors, this is very common, that it's calibration of your measuring device. That can cause problems, right? Experimental errors could be something that you collected the data very late in the sprint, and it's supposed to be collected in specific period of time. In intentional outlier, one good example, if you're doing a survey of kids underage reporting alcohol consumption, and most likely because of social norms they may underreport it. Or data processing errors, of course, when you transfer from one database to the other, when you do your ETL, that might cause some extraction errors. Data sampling error, of course, a good example of that is when you're reporting a height of all athletes and included a few basketball players, and that might skew your data set because of that. And then a natural outlier, when of course it's not artificial, it's really the data that is collected. So what we're trying to do is you have a data stream, you have a stream of data. The blank part here means it's okay, it's good data. And of course, the ones that are defective is here. So you're sending it to this data stream and you're identifying, is this current data set, is it anomalous or not? And then of course, sometimes you'll detect them, but most of the time, most of the data, there's no anomaly. And then sometimes you'll be able to detect them. Sometimes you'll be able to detect that even though it's a good data, it's detected as anomalous. And of course, sometimes, you may not be able to catch it. So it's just part of the game, part of that process that not everything get captured, anomalous or not. So it depends on, most likely you're familiar with the confusion matrix. I'm not going to explain a little more about this, but this is trying to identify the accuracy, recall, and precision the same way as you would do any machine learning models to identify how good is the model. You use that for your anomaly detection systems too. At the end of the day, of course, we're looking for a needle in a haystack. Sometimes it gets tricky, but in this case, there's that needle. There you go. So what are the different methods and how you would do how you would do anomaly detection? It either can be rule-based. You can also use statistical techniques and machine learning. And we'll discuss each one. A rule-based system is when you specify the specific rules to assign thresholds or limits, min and max, average, those kind of things. In order to detect if if it's anomalous data or not. The important part here, when you're creating a rule-based system, is that the industry experts, right, the person that knows about the data, can give you the rules, right? And what are the known anomalies? Most likely, they've encountered based from their from dealing with the data or working with the data. They've known all the different anomalies. The disadvantage of using a rule-based system is it does not adapt as pattern changes. It cannot detect, as remember, you're getting stream of data. It won't adapt there because you specify the rules just on that. Of course, if you want to change the rules, you can, but it's a manual process. And of course, one of the downside is also you have to label the data. In a way, you're looking at the data and identifying if it's anomalous or not. I agree with this. Experience is the teacher of all things. That's why you have that 10,000 hour rule, right? It's the time you work with your data, you understand. The more you understand about the data, because of your experience on it in the past and working through it, it gives you that edge. Statistical techniques. Statistical techniques is when you're deviate from the common statistical properties. You can be looking at averages, mean, median, mode, or you can looking at the moving average or rolling averages to determine anomalies or outliers. One good example for sensors, right, is what they call Kalman filters, where it's a low pass filter to kind of smooth out the data that you're getting from the sensor by using a moving average. You can also do histogram-based outlier detection. The advantage of using statistical techniques is it's more interpretable, and it's better than sometimes it's easier to explain to someone than a machine learning method. So you have to figure out that balance, which one would work best sometimes, because sometimes it can be just creating a instead of creating a model, maybe it's just makes sense to just create a filter or just look at the moving averages. So it's easier to explain to business people. Of course, there's the advantage of using anomaly detection, machine learning models versus supervised learning machine learning models. There's that advantages and disadvantages of which one would you use, right? So if because supervised learning, you can hot dog and not hot dog, that kind of thinking behind that, right? If you have your data set and be able to detect. So anomaly detection is when you have a very small positive examples. That means it rarely occurs in data. You would use anomaly detection techniques. Or if you have large number of negative examples, that would be a good, anomaly detection would be best for that. If, on the other hand, if you're using supervised learning, it would be good for if you have a large number of positive and negative examples and enough positive examples for the algorithm to learn. That does not rarely occur in your data set. And if it's your data set is about this, if you're for supervised learning, if your data set of positive examples is about the same as what you've trained it with, then it makes sense to have supervised learning. For anomaly detection, of course, there's different types of anomalies that can happen. It's not easy to learn because there's less, positive examples, and all the other future anomalies may have not been discovered yet. So that's one thing you have to consider which one you would use. So anomaly detection is best used for fraud detection. Of course, if you used your credit card and it blocked you, most likely they've used anomaly detection when when you're out of the country or you're traveling. Manufacturing, a machine, they always spin the same way or rotates the same way, and sometimes things started to happen, that's out of norm. That's when you have that's best use case for do anomaly detection. Data centers, monitoring data centers. A lot of Internet of Things application uh, uses anomaly detection. Supervised learning is good. Examples of it is email spam classification. If you think about it, there's a lot of examples, positive examples of spams out there. Another one is weather prediction, right? I mean, there's a certain set of, sunny. Of course, here in Texas, it's sunny, hot, and of course, a few times of little cold weather over here where I'm at. Uh, Cancer classification, why it would make sense to have a supervised learning, because you have experts that you can consult with, and most likely they've categorized it and they know more, and you would need a lot of examples in order to accomplish that, to make it better. So machine learning methods, you may be doing supervised learning, unsupervised learning, or self-supervised. Supervised when you use a decision tree, LSTM forecasting. Unsupervised when you have k-means or clustering, a lot of clustering algorithms, how you would use it. Self-supervised learning is when you have the combination of self-supervised and unsupervised in a way. That's when you use an autoencoder. So density-based anomaly detection, one good example here is where you have your, k nearest neighbors algorithm, and clustering-based also can be used in order to do anomaly detection where it's distance from local centroid. So like if you look at this example right here, that might be a density-based, right? Because they cluster here, anything outside of that cluster, most likely anomalous. Another one is using Gaussian distribution in order to detect anomaly, right? So if you plot the Gaussian distribution and anything outside of that norm, most likely at a certain threshold, it is anomalous. Support vector machines is also another way how you would do, and PCA-based anomaly detection. So what I'm trying to get at here is there's different algorithms out there that you can use, especially if you're doing anomaly detection. Depends on the data set at the end of the day, right? And when you use PCA-based, and sometimes when you use vector-based training. So let's go through like the Internet of Things. Internet of Things happen because sensors are getting cheaper, so that means there's more things. If you think about your phone, right? How much data does your phone collect? And for we used to have a bunch of devices out there to do all the tasks that your phone can do now. So there's increased data volume, increased data speed, improved networking with, of course, the 5G and all these different technologies that improve sending data to the cloud. Has improved. Even your network at home, how it has improved. And of course, because the data is moving very fast, failures are not tolerated. One thing that frustrates me sometimes here is, nowadays I turn off my TV using voice. using, Alexa or Google Voice, say turn off TV, because sometimes I don't have the remote control and that kind of thing. And if it doesn't work, it gets frustrated, or it gets frustrating, that kind of thing. So you become used to these type of, and of course, if there's an internet of broken things, it feels like this, right? You're trying to debug and figure out streaming set of data and knocking everywhere else. And yeah, I agree. So, and of course, there's more and more, you're going to hear more and more about this artificial intelligence of things. Where this one on the right side, where you have your real-time devices and sensors in the edge gateway sending up data to the cloud. You'll hear more about device twins and representation of your sensor data in the cloud. And then, of course, you have your business intelligence and dashboard. A lot of any one of those steps, right, can have machine learning models or AI as part of it too. So in time series anomaly, time series meaning you have timestamp and the sensor reading or number, right? You could be sales reading and then a timestamp, right? That's time series. So it could be either outlier, spike and level shift. It could be pattern change and seasonality are different types out there. Outlier would be something like, there's that trend, the between 14 and 16, and bam, something happened that the reading from your sensor data went up that high. It's an outlier, out of the norm. Sometimes it could be a spike and level shift where it's collecting data between 14 and 16, and suddenly something happened. I don't know what reason, but it's, it leveled up, right? From 16 to 18 now. So detecting these is something that might be interesting for us. And also there's that, trend and pattern right here. And then you have your sudden spike. Pattern change, pattern change can be, something where you have your machine collecting from 14 to 16, and then suddenly it's not doing properly. There's that pattern change where you have identified, maybe a car, or maybe the flow, water flows at a certain speed, and then suddenly it was limited. What happened, right? So those are pattern changes. So it's harder to detect, sometimes detect patterns, right, from your data. And of course, seasonality, we already know that. Sometimes in our data, there might be seasons. If you think about sales data in terms of ice cream sales, a lot, during summer, or, pizza sales, they said it's, pizza sales is like Halloween, and then, of course, Super Bowl is a good time for pizza sales. There's that seasonality aspect that your anomaly detector should be able to detect and identify. If you have production issues, it's like stopping a moving train, right? That's how it feels like. Whenever you start working with time series data, and you're doing anomaly detection on it, you'll see that there's this, your data set had to be identically distributed and independent from each other. That means identically distributed, that means the distribution does not fluctuate, and it's the same probability distribution. And it is independent, that means the previous reading is not connected to the current, the current reading. So one good example of that is, the roulette that you see that photo in the right? Every time you collect data, you start over, right? You start the spin, you start the ball, you throw the ball, and it's independent from each other. And identically distributed, the same number set, right? For time series anomaly detection, spikes, you wanted to detect spikes. It's a temporary burst of anomalous behavior, and change points is when does it the beginning of the changes over time, or the level changes and trends. So for in Azure, there's different places where you can have your anomaly detection, like I said on here in the cloud. So you can do ml.net on your edge devices, that closer to the sensor, right? You can do Azure streaming analytics. As you receive data from your sensors and stream up to the cloud, you can actually do some anomaly detection there using stream analytics. And of course, cognitive services can be used for the dashboard type of, Power BI and workflows and all that too can be used to have Azure. in cognitives in also if you have a specific dashboard or specific program that you have in the cloud too. Okay. To visualize what I'm talking about here, we have these kiosk, intelligent kiosk that is available on GitHub, but you can run a sample. And this one is using Anomaly Detector, which I will talk about later on. So here's what we're talking about, right? You have your data, time series data, and then the reading. So when these are, so what's happening right now is you're detecting anomalies based from the previous data readings from these patterns. And then this blue things identifies, hey, there should be, it's close to anomaly. But this one right here, it's expecting this number right here. It's expecting the number to be close to here, but it detected, hey, that's anomalous. So it's, if you look at the pattern, if this one is a machine, you look at the pattern, hey, that's anomalies. So you have that, the typical range of what the numbers should be. And then, of course, detecting if it's anomalous or not. Of course, you can change, right, the sensitivity. So the lower it is, the more it would be able to detect anomalies. Any questions so far? Is this helpful? Hopefully, it's something that kind of gives you an idea of the things that you can use in real life, right? That to be able to detect. Okay. Let's go back to the presentation. So that intelligent kiosk has an anomaly detector, and you can try it out. You can compile it and run it. It runs on I think it's a Windows app. So of course ML.net, it's an open source cross-platform machine learning framework that you can deploy in any cloud, in Azure, and it's for those of us that are C# developers that wanted to have ML into their .NET application and does not have data science and machine learning experience. ML.NET has this time series catalog that allows you to have detect anomalies. It's part of it's if it's API, so you can just call these. You have your different algorithms that is available for you. Today we'll be talking about this detect IID spike that would use okay, so let's look at the demo real quick. So I have a sample right here. It is on my GitHub. I'll post the link where to download it. But there's this. Here's my CSV file. I have this data, reading from my Raspberry Pi. The temperature and the humidity, and of course the timestamp, right? And it's every minute. And what I want to do is I read each one of those, right, and display it right here, each one of those data. I'm using the temperature and detect if there's a spike or not. Of course, I played with this data to force anomalies at the end, right? If you scroll all the way down, you know, I changed these numbers. I fudge it to make it 100 so that it would detect as anomalous, just to force it. So there's my number. It spiked up and it was detected. And the confidence level, the lower it is, the better. And you know, of course, it was able to detect like this as a spike. Also, you know, from at the last specific item. So we'll look at the code. This is ml.net. In order to use ml.net, the critical part, if you're a .NET developer, there's two packages you have to include in your program, right? The Microsoft.ml and then the Microsoft.ml.time series to get that time series catalog. So going back to the program right here. So I have my initial, you know, describing what the CSV file is. There's, you know, 1, 2, 3 columns that I'm interested in, you know, which column 2, column 3, and column 4 that I'm interested in to import to my data set. This one I'm using it to to change, because my data set is a string. I want to convert it to a float so I can pass it properly to ml.net. And then, of course, the output of my prediction as a vector type 3. So because it has to hold the alert, score, and p-values. So in order to read the CSV file, I use ML context or ml.net, right? You have to define this ML context. Once you have the ML context, that's all the algorithms are all part of ML context. You just pass that. So in this case, you do ML context.data to load the text file, place it in a data view, and then based from that data view, I can create a pipeline. And that pipeline I'm doing here is I want to add 2 new columns that would convert into a float. Of course, there's that pattern. Every time you do this, there's a fit and transform. So you fit your data to your pipeline, and then once you have that, you have to transform that, and then you'll have your data set. So here we'll do the detect spike. I call it detect spike. I'm passing in, this is that algorithm I'm talking about, the ml.net time series catalog. In this case, I'm using this detect IID spike. I have to identify, specify which columns I want to add, right? Which one I want to monitor. Like in this case, the temperature column, and then the output would be my prediction with the confidence level of 95. That's one of the parameters that it needs in order to run. Confidence level, anything. So you can identify if, I think the lower the confidence. Anyway, there's you have to play with those numbers in order to get it going. So in this case, like the confidence level for the one that is spike detected, that means 100%, right? This one is, 98%. And then the p-value history length looks at the last 25 items. So meaning this spike detected was identified because it looked at the last 25 entries, and learned from there, right? It found the pattern. So the good thing about anomaly detection and time, because you train it with the you can train it not automatic. You don't need the lot of data set or data training part. You train it as you go, right? Train it as you run it. So in this case, it's looking at the last 25 items on my data set and then identifying if it's anomalous or not. So in order to run it, in order to train it, since you don't need the data set, you just pass in a empty data model or data view. That means, and then be able to do the transform right there. And once you run it, do all the prediction, and if it's anomalous, it displays it properly. Cool. So like I said, sometimes it's better when you run it locally in your machine. So it's on GitHub. You can download this if you want to try it out. So the ML.NET 1.5, the latest one, has algorithms to detect seasonality, and a lot of the new features right there. I haven't really tried them yet. For the Azure streaming analytics or Azure Stream Analytics, you can also there's that part where you can do anomaly detection also with the data that you're receiving, right? As you receive the data in Stream Analytics. In this case, you have your IoT device, you're sending it through a Event Hub or Blob Storage or IoT Hub, and then you send that data that you receive there to Stream Analytics and then send it up, whatever results in that could be alerts through Event Hubs, Power BI. You can, there's that part. This is how you can do anomaly detection in Azure Stream. There's this anomaly _ spike and dip, the same parameters, right? What this one would do is it would look at the confidence level of 95, look at the 120 items on my data stream and train it, right, and detect it based from there. In this case, I'm looking at the last 120 seconds that I received the data and be able to send that to whatever output of that one and identify here with the score and if it's anomaly or not. And that would be part of your output. So this is the query that you would include in your stream analytics as it receives the data. There's also change point, how you would do that. So what I did here is I have ingestion data, right, from my Raspberry Pi, goes through IoT Hub, and based from the IoT Hub, you can do stream analytics. You can do your real-time scoring and then place it on a blob storage. I am not going to demo that today. I'm going to focus on the anomaly detector. But if you want to try it, there's a lot of documentation out there how you would do anomaly detection. So Azure Cognitive Services, the idea here is, it's just an API call. So Azure Cognitive Services have, APIs for web search, vision, speech, language, and there's that part that it's new now is the decision, right? Where you have anomaly detector, content moderator, and personalizer. The anomaly detector is what I'm going to demo today in a few minutes. So it's a RESTful API. No need for machine learning expertise in order to use this. It's being used by Microsoft, a lot of the product teams out there already. And it's the same. be able to detect anomalies either in real time, or you can have it as a batch. And of course, you can tweak those numbers in. Remember remember that what did you call these? The intelligent kiosk. This is using anomaly detector. So every time as it moves, it sends an API call, and then the data that it's displaying here is the result of that API call. So every movement there is an API call. So what is happening in the backend is it automatically figures out which algorithm is best based from the data set that you've sent to that API, right? So it automatically figures out, is it fine with seasonality or without seasonality, and these are the different algorithms that it can detect. Don't ask me how to implement those. I have not studied them yet, but it seems very good. So let's look at the demo. Okay, so what I have here is I have my Raspberry Pi, and what's running on that Raspberry Pi is this Jupyter notebook right there. And this Jupyter notebook, I install .NET Interactive so I can run .NET on that device. And I'm running here, so instead of Python, you can actually create a new notebook, and it would identify if you want a C# program, F#, PowerShell. I was surprised when I was doing this that there's PowerShell running on a Linux in an ARM processor. So that was interesting. So this is how you get NuGet packages, right? Kind of like in Python pip install. This is how you get these packages. So I'm using Pi Hat on top of my Raspberry Pi. It's called Sense Hat to add sensor data on it. So what I want to do is to collect temperature sensor, and also in this case, I want to play with the sensor. If I want to change the color, see if I can demo this. So just tell you, blue. Want to rerun this? There you go. It turned blue, right? So I can if I do it black, that means it turned off all the matrix sensors right there. So what I'm doing here is I'm collecting data from the Raspberry Pi, collect temperature data in Fahrenheit, and add it to my list. And as I add it to my list, I round it up. I round up the reading, because here's what I want my data to look like. Round to the nearest minute with that temperature reading. So you have all that at certain. So every minute it would capture sensor data and add it to my list. So Anomaly Detector, since it's an API call, there are lots of packages that wraps, like in this case, there's a NuGet packages in C# that wraps the API call for Anomaly Detector. So instead of, dealing with changes of that API, that NuGet packages allows us to be able to do updates later on and keep the API pretty much about the same. So what I'm doing there, once there's this get series where I need to, in order to call that API, I need to create this request object. This request object requires me to pass my data set, meaning the time and my time series data, and then specify, hey, my time series data is every minute and it's every 1 minute. and that would be my, that would be part of my request. And this one right here is calling the API, this Anomaly Detector client, and calling this last detect async. And this last detect async would pass in the request, and it would, whatever that response would be, I would check if it's anomalous or not. In order to use the API, you need two things. You need the endpoint and the key value. The endpoint identify where, what's the URL. So you have to sign up in Azure for this Azure Anomaly Detector instance, and then it will give you an endpoint and the key. In this case, I have it in this config JSON, but you can just, once you have the endpoint and the key, read that. This one creates the client. You pass in two things. You have pass in the key and the endpoint, and now you have the Anomaly Detector client on here. So I'm listing what my data is. I'm tricking it because I want the last item on my list to be anomalous, right? It's just easier to explain, right? Because the data is 97, and then the last item is 200. So that would be detected as anomalous. And so I pass in all my temperature data, and then I call this is the last item on my list anomalous. If it's anomalous, then I check and turn the matrix to red. So let's try to run that program. Right. So let me try to run it. So shift enter. There you go. It turned red. Well, the reason why it turned red, these are my data and what I passed into. Of course, I ran it 3 times already. So the last 2 items was detected as anomalous, and change my alert or change this LED matrix to red. And of course, that is too bright and it's hurting my eye. I want to turn it off, so I change it to black. So that's just an example what you can do with Anomaly Detector. Anomaly Detector, you can use it in C#. There's also, you can use it for JavaScript and Python. So that means you can also add it to a Docker container. So there's examples out there incorporated with Power and Azure Databricks for streaming data. So instead of streaming analytics, you can use it in Databricks also. So in conclusion, the best superpower that you can give to any IoT project is that Spidey Sense, being able to detect anomalies. And if you want to download a copy of my presentation, feel free to go to this link that is posted here. I will post it in the chat after a few minutes. And there you go. You got stung or you by this spider. So feel free to be able to try out these anomaly detection algorithms, anomaly detector. Feel free to try out ML.NET time series catalog. And my name is Ron Dagdag. I'm a lead software engineer at Spacey. It's my 4th year as a Microsoft MVP. The best way to contact me is using LinkedIn. My Twitter handle is at Ron Dagdag, and I appreciate you geeking out with me about Spidey Senses and anomaly detection. Have a good day. Thank you. Any questions? I'm ready for questions.
Thank you, Ron, for this wonderful session. Looks like we don't have any questions so far, at least in the chat window. So folks on the line, if you have any question, feel free to post those questions in the chat window or just unmute yourself and ask the question.
Yep. Isn't that cool? we've done today. I think it's very interesting how you can do
Yep.
anomaly detection, made it easier. And if you have a business case, this is easier to pitch to someone, uh, in the business management, because it in a way it's easier to pitch them compared to like other computer vision projects, or or machine learning project, because sometimes it's it's something that might be able to help day-to-day lives, especially if most likely have some rule-based systems out there that maybe it makes sense to have to be converted to anomaly detection. So that's my take on it.
Yep, I agree. And thank you very much, Ron, for this wonderful session. And there is a one comment. Did you share your GitHub address? Can you quickly post those link in the chat window so attendees can have that? And
Yes,
also,
I will post them. Yes.
okay, and also, thanks for joining us today. The dates for the next event are posted in the chat window. The next conference will have on February 5th. After that, we will have on April 2nd, and then on June 4th. So thank you very much for joining us. Stay safe and stay healthy, and happy Thanksgiving in advance. Thank you, everyone.
Thank you.